Alright, welcome back everybody. In this video we're going to look at how we can use the shell method to find the volume of solids generated by revolving regions around the x-axis. In the last video we did it with regions around the y-axis. So it's the same general concept, except remember from the last video when we went around the y-axis everything had to be in terms of x, and our strips that we were working with were parallel to the y-axis. Now everything we want to use in our integrand is going to be in terms of y, and we're going to do it with respect to everything in the integrand is going to be in terms of y, and our strip is going to be parallel to the x-axis. So I'm just going to draw in a quick coordinate plane so I can sketch these equations quickly. There's our coordinate plane, and we've got the equation y equals 2x minus 4, looks something like that. And the line y equals 0, looks something like that. And x equals 3. And the region that we're revolving is this region right here. And so my strip in this situation is going to be parallel to the x-axis. And when I integrate all this stuff, it's going to be, I want to have x as functions of y. So the line x equals 3 is already solved for x. I need to solve the equation y equals 2x minus 4 for x. That's easy enough. I add 4 to both sides and divide both sides by 2, and I get that x is equal to 1/2 y plus 2. So that's the equation of that line in terms of x. I'll be honest, this is kind of an artificial example. There's no way I would ever personally use the shell method to find the volume of this solid going around the x-axis. I would just use the disk method, but I'm using it as an illustrative example to show you how to do it. We'll talk more in the next couple of videos about when to use what method in which situation, and that'll clear some things up about when it's best to use these. But for now, we're just kind of looking at the mechanics behind setting up the shell method going around the x-axis. So we want everything to be in terms of y in our, in terms of y in our integrand. So we've got 2 pi times the integral, and my limits of integration are going to be y coordinates at the ends of the region. So we've got the bottom of the region and the top of the region as our coordinates. The lower limit is going to be 0. The upper limit is whatever the y coordinate is of the intersection point of x equals 3 and the line x equals 1/2 y plus 2. That happens at a y coordinate of 2. And so we're going to integrate from 0 to 2. And now we'll set up our integral. First off, we need the distance that the strip is from the axis of rotation, and that's just going to be the y coordinate of the strip, since we're going around the x-axis. The distance from there to there is y. And then I need the height of the strip, and I'm going to take the bigger minus the smaller, which in this case is the more right minus the more left. And so x equals 3 is the rightmost line, and x equals 1/2 y plus 2 is the leftmost line. And there's my integrand setup that I'm going to use to find the volume of this region using the shell method. So I'll break out my handy dandy calculator now, and I'm going to have 2 pi 2 pi times the integral of, and in my calculator I'm going to use x since I don't have the y as a choice. Close the parenthesis, close the bracket, respect to x from 0 to 2, and I get that the volume of this solid is 4.189. Now alternatively, just to show you this, like I said, I would use the disk method on this one. I could have used the disk method and it would have been pi times the integral from 2 to 3 of 2x minus 4 quantity squared with respect to x. And if I calculate that value, I should have pi times the integral of quantity 2x minus 4 quantity squared with respect to x from 2 to 3, and I get the same value for the volume. Okay? We'll talk more about when to use disk, washer, shell in our next video. Alright, example 2, we're going to use the shell method to find the volume of a solid created by revolving the region bounded by y equals 2x, y equals 4 minus x squared, and the x-axis around the x-axis. So we've got the line y equals 2x, looks like this, the parabola y equals 4 minus x squared, looks like this. Oh, and the x-axis. Which region am I talking about? I'm talking about this region in here. I should have said in the first quadrant. So there's my region. I'm going to set up my strips. They're going to be parallel to the x-axis, and I want everything to be in terms of y. So solving these equations for x, this is x equals 1/2 y is the line, and the parabola turns into x equals plus or minus the square root of 4 minus y, where this right-hand side that I've colored in red is the positive branch. So that's the one that we're going to use in our integral. And now I'm going to set things up. I've got 2 pi times the integral from one end of the region to the other. So in this case, we're going from the bottom to the top. The y value for the lower limit of integration is going to be 0. The upper limit of integration is where this line and this parabola intersect. So where is that going to happen? Well, do I know off the top of my head? I don't. So I'm going to go ahead and graph these and find the intersection point. And we'll look at the graph of these. And I should have looked at my window first. Let's go to a standard window. Alright. And the intersection of these two curves. That happens at x equals 1.236, but we want the y coordinate. It's going to be 2.472136. 2.472136. Okay. Next we need the distance that the strip is from the axis of rotation. That's going to be y. And we need the height of the strip, which is the parabola, positive branch, minus the line. And there's our setup for how we're going to find this using the shell method. Now, unlike the last example, I might actually use the shell method for this one because I'd have to break it up into 2 separate integrals if I wanted to use the disk method. So, maybe I'd use the shell method in this case. Let's go ahead and calculate this. We've got 2 pi times the integral of y times quantity square root of 4 minus y, close the square root, minus 1/2 y, close the bracket, respect y. And every time I type x in this case, I'm saying y because that's what it actually is in the real situation. And I'll go ahead and calculate that. And I get that the volume is 13.404. So that's the mechanics of how the shell method works when we're revolving things around the x-axis. That's the end of this video. See you next time. Have a great rest of your day.